Hello, everybody. Can you hear me? I don't know why I'm asking because I don't think you can respond. Let's see. If I am just closing that. And let's see. I'm also watching you through AV Tutor. Hello, hello, hello. Sorry about the wallpaper. And sorry I'm not with you today. I had my knee surgery on Tuesday, so I'm on crutches and not able to move much. But I still wanted to teach you, and I wanted to go through a couple of bits and bobs today. So I'm going to be in the room, sort of ish, but also watching over AV Tutor. So if you need any help, then please ask on your screen or something. If you're okay, let's get cracking. Let's see if this actually works. Now I put on a PowerPoint before. I'm going to put that on again. This one here, and you should see a random teacher with a whole bunch of arms. Now, the question here, it sort of links to what we're going to be talking about in a moment. Would you rather have all of your lessons taught by your sixth form tutor? So everybody in your tutor group at the moment, you get to stay in that room all the time, and your sixth form tutor would teach you every single lesson. Now, obviously, that's not a massively good solution. And it's because you want your teacher to be a specialist in the subject. You want your teacher to have a designated time where they teach you and other people in that subject. And we like it to be sort of layered. So one layer would be your computer science A-level taught by Mr. Lister. One level would be your maths A-level taught by Miss Pex. One level will be your physics A-level taught by Miss Lydon, and so on. So you can have different levels of education, which is teaching you. Thinking about today, and that's going to lead us on to what we are doing. Now, the first thing I want us to know about is we need to be able to, we're understanding at the moment about how data is sent across a network. And we're thinking about different characteristics of a network, but in particular today, we're thinking about this middle learning objective. We're thinking about protocols and standards, what they are, how they work, and the purpose of them. And there's a few things. There's a bit of an experiment. Well, this whole lesson's a bit of an experiment. It's a bit of an experiment to see if this actually works. Okay, so I'll know whether this is working in the next 2 minutes, I think, because I'm going to give you a task to do, which should hopefully work. Okay, I went through these last lesson. I'm going to go through them quickly. Protocols are the rules that govern computer communication. That's the sort of key phrase that we need to know, the definition. They're the rules that allow two or more computers to communicate in particular ways. And there's a number of them that we need to be aware of. There's one of them that we need to know really well. These are the ones that we need to be aware of. HTTP is Hypertext Transfer Protocol, and that's used to share text across the World Wide Web. So it's used to allow websites to display information that we can use. HTTPS, exactly the same, but the data is secured. It's encrypted when it's sent across the World Wide Web. POP, this is called Post Office Protocol, and it's when emails are downloaded onto a server before being read. So the way I access my emails is I use Microsoft Outlook, which means that my emails are downloaded from the internet, put onto my laptop, and I access them from there. Whereas you use IMAP. That means you access your emails through the internet. You have to go to a browser, log into OneDrive, and access your emails through there. There are two different sets of rules that the computers understand that allow this to happen. One allows the emails to be downloaded, and one allows them to be stored on a central Exchange server and read online. And the other one is FTP, which is a file transfer protocol, which allows files to be sent across a network or from computer to computer. Now, first off, this is how I'm going to know if this is working or not. Could you go to this link? And you might have used a Padlet or a Woolwisher, it used to be called. Could you basically do this? List me those 5 different protocols with just a really brief description about what they are. Just I want to see if, or as many as you can. If you can't think of 5, it's basically these 5 here. If you can't think of 5, then think of as many as you can, and give me a little bit of information about them. Okay, I'm going to go dark for 2 minutes while I give you a chance to do that. So let's see what happens. Can you hear me now? Somebody drop me an email to say whether you can hear me or not. Sound is working, I hope. Okay, I think chat is enabled. So feel free to send me a... Blimey, I'm being swamped by... Somebody just got a print screen. Who's anonymous? Send me a print screen of my slide. Okay, I'm going to prove just a couple of them that are spot on. Wow, I've got loads of them. Okay, let's close you down. Close you down. Let's a preview. Okay, if you stop what you're doing for me, guys. So if we pause what we're doing, then I will have a little look and find a really good example to show you. I've enabled chat on the video, so you should be able to leave me some comments. G13. Okay, let's have a little look. Let's find, I'm going to delete a few of them. Sorry, this is going to be a bit cold. So let's delete a few of these and let's focus on the one. Well, Johnny's is there, it's all right. Let's have a look at Nathan's, is all right there. Anonymous, got all of them listed. Good, so it looks pretty good to me. Are you able to delete your own notes on that Padlet thing? If you are, could you remove them? So I've just got a clean board. Okay, let's go through approve, 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 approve. Okay, that looks good. That looks good. Got a few of these that have been removed. So let's keep a couple of them. And let's keep here. Delete. Okay. Delete. Okay. Delete. Okay. Right, got a couple there. Stuff. Keep Gavin's on there. Right, okay, back on it. So I think we are in the right sort of place. Who's called McLovin? Jeez. Okay, where are we? Let's go back to the presentation, which is here. Okay, now, this next section is IP addressing. So thinking about the more advanced protocols. Now, every single computer on a network has its own IP address of that computer on the network. So if I wanted to send a piece of information from my server to my switch, it needs to know where to go. It knows where to go via its IP address. Oops, the MAC address is unique to that computer, and the MAC address doesn't change. The IP address will change depending on where that computer is plugged into the network. So if these two computers swap positions, then they would have different IP addresses. The MAC address would always stay the same. So the IP address is the address of that computer on a network. Now, each network, each LAN has its own IP address as well, which is different to the local IP addresses. And what I mean by this is that the IP address that you access when you go to Google, when you go to Yahoo, when you go to MSN.com or anything like that, it's got its own IP address for that network. However, when you go inside the network, each client within there has its own separate IP address. So if you wanted to communicate with a particular computer within a particular network, you need to know their network IP and you need to know that client IP as well. So you need to know two different things. So the computer you're logged onto now has got your own individual IP address, the school's IP address. So if I wanted to communicate with you now, I would need to go through the school's IP, and then I'd need to go through your individual IP. So my message would need to have two IP addresses sent to it. And this is what TCP IP does. This is the main protocol that we need to have more of an understanding on. It's a transmission control protocol that works with our internet protocols. And it's the communication tool that allows computers to communicate and send information across computers in a network, whether it's a LAN or a WAN. Each computer that connects to the internet has its own TCP IP program that allows it to communicate with other computers. This computer, this TCP IP, does a number of different things, but it does them in layers. It's a bit like when you're being taught, if you were taught by your tutor would have to teach everybody one thing at a time, or they'd have to try and muddle together to get everything done. The TCP IP manages everything it does in different layers. So it does one thing at a time to make sure that the communication is well structured, to make sure the communication is clear, and to make sure the communication is simple. So TCP IP is the main one that we're looking for. And the way we remember it is a turtle never lies. From your childhood, you might remember the Teenage Mutant Ninja Turtles were the greatest superheroes of all and massively trustworthy. So if you remember a turtle never lies, then you'll be all right. The application layer is the first layer, which we're going to be looking at. Then we've got the transport layer, we've got the network layer, and we've got the link layer. So there's 4 layers to the TCP IP. By layers, I mean things that the TCP IP does, 4 rules that it needs to follow for things that happen to allow two computers to communicate. And I'm going to go through each one of those. The first thing that will happen is the application layer. This is when you would ask the computer to do something for you. And let's take an email as an example. If you wanted to load up a web page is another example. If you wanted to send a file, that's another example. But we're going to use email as an example. And the TCP/IP would allow the application layer of the TCP/IP would allow the email to be written and allow the email to be sent. So a bit like a web browser, a bit like Microsoft Outlook would work with the TCP/IP application layer. When we put an email address in or an IP address or a web address in that we're trying to communicate with, our DNS will turn that into an IP address, which I'll talk a bit more about the DNS a bit later on. I'll give you an example. This is an email that got sent from student A to student B in a different college. And the email just says the protocol stack isn't too complicated a topic when you think about it. Layer will allow you to send an email, will allow you to compose the email, write it, and allow the user to do something. That's what happens in the application layer. The first thing the TCP/IP does is it allows a user to send an email. Once the computer at the other end has received the email, the application layer allows them to open it and read that email. So it either allows you to send the email if you're the sending computer, or open the email if you're the receiving computer. So that's what the application layer does. The transport layer, what this does is it creates a virtual connection between the two computers. So as soon as I've written my email and press send, the transport layer will then come into play and it'll create a link between those two computers. My message into packets. As we know, packets are small, equally sized chunks of data that aid communication. They allow communication to be more efficient, more secure, to go a lot faster around a network and improve the network efficiency. So our data is split into packets. When the data is received at the other end, the transport layer goes again and it will reassemble them. So when we're sending it, the transport layer will dismantle our data into layers. When we receive it, the transport layer will reassemble it. Also, when we receive it, this is where error checking takes place, which is what we talked about a bit last lesson. So things like checksum, parity bits, and echoes. A bit like this. So I've broken my email down into two different sections. The number 1 and the number 2 stand for, they stand for the packet number. So we know when they arrive at the other end, we know what order they arrive in. There were two different ways that these packets could be sent, circuit switching or packet switching. We talked a bit about those last time. Now, the network layer. What this does is it's, at the moment, our packets have a packet number on, but they don't know where they're going. So they just have, this is the order that they need to go in, this is the order they need to arrive in, but they don't know where they're going. So the network layer is going to add the IP address to them. And once the IP address is added, they become something called a datagram. And that's the official technical term for the packet that includes the IP address. It's called a datagram. The datagrams are then ready to be sent across the... When the datagram is received at the other end, the computer, the receiving computer, will take the IP address from the packets. A bit like this. So now I've got the client IP address, so the computer I want to access it, and I've got the server's IP address. So I'm going to send it to the second IP address, which is the network IP, and it's going to be received by the first IP address, which is the client's IP, because we have each computer within the network has an IP address, and each whole network has another IP address. So you have an internal and an external. The client IP is internal, the server IP is external. The link layer. This is when we add the MAC address to the packet, so a bit more information is added, and when the data is actually sent. So the method of communication is decided and sent. If it's going to go wirelessly, it needs to be sent in a particular format. If it needs to go across a wire, it needs to go in a particular format. If it goes via satellite, the same. And it's the link layer is how the data is actually sent. So we have 4 layers. We have the application layer, which allows the computer the data to be sent. Sorry, the data to be composed or to be read by the user, so when a human can actually do something about it and read what's going on or interact with it in some way. We have the transport layer, which is when the data is split into packets and the packets are numbered, so they know what order they need to be in. We have the network layer, which is when the IP address is added to each one of those packets. And we have the link layer, which is when the data is actually sent to the computer. Okay, that's what the TCP/IP layer is. Could you, how can I do this maybe a bit better, because I was swamped with different things. Number one, could you put your name on? You add a new sticky note thing to that Padlet, name to it, and then just give me a quick one sentence. What does the TCP/IP stand for, and what is its purpose? And I'm going to select a really good one to keep. Let's say 2 minutes. Add yourself another thing onto that same Padlet wall. Okay, let's get back on it. Looks good. There were some really good ones on there. Just trying to go through and find a great one. Gavin's looks all right. Gavin's just been used before. Let's see if we can find somebody else. Let's see. Quite a few of them look really good here. Somebody's just written, Michael's just written, a turtle never lies. Thank you, Michael. Anonymous, yours looks good. Let's keep yours. Okay, I'm going to delete a few of these. God, how do I stop doing this? I think I'm deleting a whole bunch of stuff. So can you start deleting your own ones, please? Except for there's two on the right-hand side, one by Gavin and one underneath that. I'm not sure who wrote that one. So for your one, could you delete all of them except for the two on the side? Because I think it's easier for you to delete than me to delete. Okay, right, this one, what am I going? I'm going to the wrong page. This question, I think it's probably not best to do it straight on a post-it note. Could you add notes somewhere to your official documents, whether it's electronic or whether it's in your books, that's going to basically answer me whichever one of these three questions you want? What the protocol is, what TCP/IP is. We need to know a bit about the different layers. For the highest marks, you need to know what the difference between the transport layer when you're sending data and the transport layer when you're receiving data. So you need to have an understanding about both sides of that, if that makes sense. So just for the basic grades, we need to be able to define the TCP/IP stack. For the middle grades, you need to be able to give me a bit of information about how it works when data is sent. And for the higher grades, you need to be able to tell me how it works when it's sent and when it's received. Okay. So I'm going to give you, what's the time? I'm going to give you about 10 minutes to make sure you've got any notes. I'm not sure if you've got this PowerPoint. If you haven't, I'm going to email it through to you now. So you've got these notes there ready. So check your emails. If you're really not sure, I haven't got a clue, then drop me an email with a question or write a question on the comments. But I'll send you through this PowerPoint now. Or I'll share it because it's a Google document. So I'll share it with you now. And I'll be back at, let's say, about 1:45, 10 to, around that sort of time. So use this time now to write up any notes. Make sure you have some understanding of these bits here. Ask me any questions. And in about 10 minutes, we'll be back together. Another 3 minutes, then I'll bring it back together. I can see your screens, you know, so those of you watching stupid YouTube videos that should be doing work, do work. Don't waste time. Okay, last couple of bits we've got to go through, and then I will leave you alone to enjoy your lunch. Just as a note, I am doing this out of the goodness of my heart, so please don't waste time by doing random things that you don't need to be doing. Do the work that I've asked you to do. Okay, domain name server. This is when we type in a website, when we type in an email address, a computer will obviously not understand what that bunch of random letters means, so it needs to turn it into something it does understand. What computers can understand is numbers in a little way. So every single web address, every single URL is transformed into an IP address for a network. So when I go to google.com, I'm actually want to go to the IP address of the Google server. The way that's done is through a domain name server. And a domain name server is a bit like a big list in an Excel spreadsheet of every single website, along with the IP address of that server for that website. So when we go to Google, we actually open up this DNS file, find where it says google.co.uk, and then finds the relevant IP address and uses that IP address. So what the computer sees is a whole bunch of ones. These are turned into little packets like this, which are then turned into an IP address for a network, which is then turned into an actual URL that we can understand. The reason we have a domain name server and we don't have a, well, we're not expected just to type into Google every single IP address for the networks that we want to go to or the websites we want to go to, is that humans aren't very good at remembering numbers. The individual IP address for every single website we wanted to visit, it's a lot more difficult than going to bing.com. So that's one of the reasons we have it, is to allow users to not make mistakes, allow it to be quick to access websites, allow it to be user-friendly to access websites. What we see is google.com. What the DNS sees is the IP address for that particular website, for that particular web server. And what the cables see is the binary and the electricity that goes through in a particular pattern. So that's what a DNS is. What happens is we would search for a particular website. So we're going to search for www.amazon.co.uk. The computer will then look up amazon.co.uk on its DNS. The IP address of the domain name is found and the computer accesses the network. And data is sent back to the computer from the server. Go through, we'll find amazon.co.uk. There's quite a lot happens in between the bottom two boxes, but we don't need to go into a lot of depth on that right now. Well, what happens is we go to amazon.co.uk, we type that into Google Chrome. Our computer will then resolve the IP, which basically means turn amazon.co.uk into an IP address, and it will navigate to that particular part. So using the TCP/IP protocol, we were to use the application layer to type in www.amazon.co.uk into the web browser. The transport layer will then we'll then split our request up. The transport layer, the network layer, sorry, will add the IP address that was found on the domain name, and the link layer would send our request through to the Google service so it can retrieve the information. This all happens theoretically at the speed of light, as long as we're using the correct transmission media or fiber optics. So that's what we need to know about. You also need to think for the higher marks, how does it go back the other way? So how does it work once the data is being received? How is it sent back and how is it transmitted? This is what we need to know. So I'm going to give you a few minutes now to add up any notes about the DNS into your notes. So what I'm looking for is, just for a basic level, what is a DNS and how does it work? And for the higher levels, think about what will happen if an IP address cannot be resolved on your DNS. So your computer's DNS doesn't store the IP address for amazon.co.uk. Does that mean that you can't visit amazon.co.uk? Something that happens, what is it? So I'll give you a few minutes to add a couple of your notes, then I'll go through that bottom question if you haven't managed to find out what the answer is. I'll go through what happens at that bottom bit there. So a couple of minutes, unless we'll bring it back together. There's still one more thing I want you to do. So let's bring it back together in a couple of minutes. The last thing I'm going to teach you is client server and peer-to-peer network. I don't think I'm going to have time to teach it properly, so that will wait till next week when I'm back in. It's only about a 10-minute, 15-minute thing, but I don't want to rush through it in 5 minutes. So we'll do that next time. Once you've finished writing about DNS and you're happy with your TCP/IP stuff, then I've emailed you a little link just to see a quick survey, just to see if this was any good or not. So please rate a couple of things on a scale of 1 to 5, just as a quick. This is the wallpaper. So it'd be great to get some feedback on that as well. And that is it. So I'm going to stop broadcasting now, but I'll keep the comments open so you can still keep asking me questions. So your task now is to finish off your notes on DNS, finish off your notes on TCP/IP. The last little bit. As soon as you've done that, then wait till the bell, and then I'll see you all next week. But please complete that little survey. Just give me a bit of feedback on whether it's not, whether it's good or not. And that's it. Bye-bye.